Hello everyone, welcome to our today's video. Every developer wants to learn a technology which is very trending in the market, and every data company or any of the organization wants to use the best data warehousing solution if it is available in the market. And now Snowflake is very hot in the market. Everybody wants to use that because of its capability, because of its unique features. So in this video, we will also discuss about the Snowflake, what is it and what are its unique features. Snowflake is a cloud-only data warehouse. What does it mean that it's a cloud-only data warehouse? So it simply means data warehouse which is completely hosted over cloud and can only work with public cloud like AWS from Amazon, Azure from Microsoft, and GCP from Google, and cannot be used with private or hybrid cloud. If I talk about if you want to use Snowflake in any of the solution, do you need to install any of the software or any hardware is needed? So no, it doesn't need any of the thing because it's a SaaS offering. SaaS offering is a software as a service. That means data warehousing. It is being provided as a service. So no hardware installation, no configuration, nothing. It's just a service. So you just need to use it. Since it is a data warehouse, so we need some language to deal with it or some kind of construct to handle the data, right? So here we have Snowflake SQL or the SQL, which has primarily all the features like DDL, DML. DDL is a data definition language, which is used to create data objects like data, schema, tables, and DML is a data manipulation language, or can call it as a data processing language, which we can use to write our business logic to retrieve the data to do some queries. Another thing is SQL functions. Like we have couple of functions like scalar functions which return a single row as an output and takes single row as an input, like date time functions, encryption, or you can call it string functions like concatenate, substring, aggregate functions. Also we have here window functions, table functions. Important part which is UDF and stored procedures also there, which you can easily write it here. So now UDF is user defined functions or the customly written functions which let you extend the system to perform operations that are not available through built-in or system defined functions. And in Snowflake, you can write UDFs using Java, JavaScript, Python, or SQL, and these functions return scalar or tabular results. Now, another thing which you want to discuss about is the stored procedures. So stored procedure is nothing but a prepared SQL code that you can save so that a code can be reused over and over again. And these stored procedures allows you to use programmatic constructs to perform branching and looping, which is not possible with the straight SQL. And with stored procedures, you can perform error handling or you can create a SQL statement dynamically and execute it. So isn't it a powerful tool? And in Snowflake, we can use Java, JavaScript, Python, Scala, or Snowflake scripting to write a stored procedures. But mostly JavaScript is most preferable to write the stored procedures. Now, the most important feature, or I would say the concept which is available in Snowflake is that they have separated out storage and the compute part. Both are separated, both are totally independent. So if you want to scale up a compute layer, you can do that independently of the storage layer, and it is vice versa. Now if we talk about the storage layer which holds data, tables, and the query results for the Snowflake, and Snowflake totally relies on the scalable cloud blob storages available in public clouds like AWS, Azure, GCP. And if we talk about how this storage layer stores our data, organizes it, so Snowflake organizes the data into multiple micro partitions that are internally optimized and compressed. Data will be stored in a columnar format. Now, to run the queries, compute layer has to connect with the storage layer. And for storage layer, we have to pay for the average monthly storage used. So now, compute layer is nothing but virtual machines only, and we call them here as a virtual warehouses. In AWS, it is EC2, and in GCP, it is compute engine. And these virtual warehouses can be created based on our requirement. So let's say if you want to run a just DDL statement, then you can spin up a very small size virtual warehouse that will work fine, or one node or two node. If you want to run a data load query, then medium size, let's say 4 node cluster, virtual warehouse can be spinned up. And if you have some very complex data processing logic, some business logic is there, and that you have to execute it on a very high amount of data, then you can spin up an extra large or double XL 16 node, 32 nodes cluster that you can skin up and perform the processing part. So here, depending on a requirement, you can spin up the virtual warehouse depending on your need. So that is how Snowflake lets you perform the data analysis, keeping your storages and your cost at a bare minimum level, because you have to pay for what are you using. So let's say if you want to run a query for 30 minutes, so you have to pay for only 30 minutes. And if it is taking a 10 minutes, you have to pay for 10 minutes only. So there is no extra cost on that. Now, there are certain unique features about these virtual warehouses which we have in Snowflake. So virtual warehouses can be scaled at any point of time without impacting your running queries also. So virtual warehouses can be set to auto suspend or auto resume. And let's say after a certain period of inactive time, you're not using it, right? It's inactive. So it will automatically get suspended. And when you submit a query, it will get resumed. Isn't it a unique feature? Now we'll discuss about a little bit other different unique features that are available. First one is a time travel. So time travel is a very powerful tool which enables historical data to be accessed. Like you can access historical data that has been updated or the deleted within some defined time period. So with this, you can restore your data related objects like tables, schemas, data, TVs that might have been deleted accidentally or intentionally. Now the another feature which we have is data sharing feature. So with this feature, you can share your data with another Snowflake accounts. Now the another feature, zero copy clone, data cloning, which is a very interesting feature. With this, you can clone any of the data objects. Like you want to clone a table A, you want to clone it into a table B. Now if you do clone, table B is totally independent of the table A. You can even write it this data. You can do any sort of operations on that independent of the table A. Although table A was a source for table B. But in data sharing feature, this is not the case, because in data sharing, it's a read only. But in data cloning, you end up in a creating writable data objects. Now in Snowflake, all the popular connectors are there, JDBC, ODBC, or all the sync source connectors are there. And if I talk about the billing model, it's a pay per second. So as I was explaining in the compute part, you have to pay for what time, for what exactly the seconds you are using. For that same amount of time, same amount of seconds, you have to pay. And for non-Snowflake users, Snowflake has provided a reader's account. Now, if I talk about the security, so Snowflake is providing a whole lot of security features like RBAC, DAC, DAC. So let me explain a little bit difference about the RBAC and DAC. So RBAC is a role-based access control. So Snowflake lets you allow to create a role. Under this role, you can assign some of the users, and whatever roles and privileges or accesses you are going to provide to this role will be inherited by the users you have added under that role. While contrast to this, DAC is a discretionary access control where each object has an owner, and the owner in turn grant accesses to the object to other users. Now, another feature which we have is column level masking. So which is available in most of the data warehouses, like PII data should be masked out. It should not be visible to the unauthorized person. And the last but not the least is a row level security. So the authorized persons will be able to see the rows when they query the table or any of the data object. They will be retrieving only the results which they are authorized to. So with this, I'll wrap it up. And in the next video, I'll discuss about the Snowflake architecture, the hybrid architecture, shared disk and nothing shared architecture. I hope you enjoyed this video. Please like, share and subscribe and stay tuned for the next video. Thank you.